Okay.
That's good. Yeah.
Okay. Good afternoon. I am Joe Fujikura. I present an attempt to build a system to facilitate experiential knowledge sharing through voices of conversations embedded in specific situations. For example, as a digital fabrication studio, we often have conversations including tips situated in actual experiences like this. The aim of our system is to virtually embed such voices of conversations in the specific situation and automatically extract and provide to users in similar situations. In order to convey such information to others, most previous work on augmented reality has used visual presentation with heads-up displays. However, the visual presentation tends to disturb the user's foreground work. On the other hand, we believe that audio presentation is better for ambient presentation of such experiential knowledge in the fields. In this talk, we discuss the effects of ambient display of past conversations to users' experience, that is, conveying the knowledge and behavior change caused by them. Let me start with the video illustrating our system. He is working in a digital fabrication studio. Our system provides him with voice of past conversations embedded in specific contexts through his neck speaker. He can hear the voices without stopping with his work. In order to segment and retrieve past conversations from vast amounts of captured data, we focus on nonverbal contextual information, that is location, attention targets, and hand operations of users. He comes into the studio and approaches to the workbench. Here, his current location is sensed to workbench. When 5 seconds pass after his location is detected, the system extracts a past conversation embedded in the same location and provides the voice to the user. He leaves from the workbench and approaches to a 3D printer. You can see the changes of contextual information along his behavior. First, location is detected at 3D printer area, and after 5 seconds, a new conversation is presented to the user. Here, his attention goes back and forth between the 3D printer and its PC. Here, his hand operation is detected as button operation. When 5 seconds pass after his specific situation is detected, the system provides him with the conversation captured in the same situation. Therefore, the more detailed the situation is detected, the more specific conversations are provided. Hereafter, we show some examples that our system successfully presents knowledgeable conversations to the user. We conducted experiments to confirm the effectiveness of our system. I'll talk about the experiments. We have prepared the conversation corpus for our system. We held workshops of digital fabrication 3 times and video recorded the participants' conversations and their behaviors. Next, we checked the recorded video and extracted conversational scenes. We built the list of conversation scenes containing of contextual information of the conversation participants, that is their location, attention target, and hand operation. As you can see, the lower tables, the conversation scenes are distributed according to various values of the contextual information. The total number of collected conversation scenes is 304. The length of the extracted conversations varied from 2 seconds to 155 seconds. Average length of the conversations is about 37 seconds. In order to evaluate the effects of our system, we conducted experiments because we encountered the difficulty of real-time sensing of contextual information. We use the Wizard of Oz method. Our research question is if past conversations can convey timely knowledge to the users in specific situations. We confirmed this question by observing changes in participants' behaviors. We asked pairs of participants working in the digital fabrication studio. We experimentally observed their behaviors and judged the changes of contextual information, that is, location, attention targets, and hand operations, and input them into the system. One of the participants wore a wireless earphone for hearing the voices presented according to their situation during their work together. Despite the sensing of contextual information was done manually, retrieving and presenting conversations according to the direct situation was automated. As I mentioned, our conversation compass has 304 pieces of conversations distributed in various locations. In this example, the user approaches the 3D printer area. Our system has 94 pieces of conversations associated with the 3D printer area, still a huge amount. If 5 seconds passed without change in the user situation, our system randomly selects one conversation from the 94 candidates. So the selected conversation may be different from the actual situation of the user. The user can ignore unrelated conversation, but such unrelated conversations may give a chance to meet new knowledge. If the user turns his attention to the 3D printer for 5 seconds, the candidate of conversation becomes narrowed down to 47 pieces. The system selects one put of 47 randomly at this stage. If the system detects the user's hand operation, button operation in this example, the detected situation becomes more specific. Accordingly, the candidates of provided conversations becomes narrowed down to 8. In such specific situation, we can expect that the conversation presented to the user will be more precisely matching to the user's current situation. We conducted an experiment. In the experiment, participants performed tasks while listening to the conversation. The task in the experiment was making a wooden box. It's the same task as the workshop. We collected conversation data. We asked the earphones wearer to verbalize what they thought as possible. We also conducted another experiment with different tasks. The reason was to confirm if our users can utilize presented conversations even when performing different tasks. The task this time was making a maze. Participants were the same as experiment 1. This is the overview of experimental results. As shown in this table, we could find totally 6 conversations that affected behavior through 2 experiments. One conversation was selected by 3 situations, 4 was selected by 2 situations, and 1 was selected by 1 situation. From these results, we can see that just selecting conversations based on location and attention targets can provide useful conversations. Despite the number of successful scenes is small, the result is not so bad in the sense that the provided past conversations changes the participants' behaviors effectively. There's only one thing that we could find good effect of provided conversation in the case of different tasks. There are several reasons for this. First, it was difficult to work while paying attention to the conversation. Two, it was difficult to apply the conversation presented by the system to the different task situations of experiment 2. Let me show some successful examples in detail. This is an example in which participant A has learned from the conversation about the filament exchange operation. They forgot how to change a filament. There was a conversation just about changing the filament. Besides, we could share knowledgeable conversations using only location and attention target. Here is the conversation presented by our system at the time. They could operate the device in the correct procedure by presented conversations. This is another example. This is the example of participant C getting knowledgeable about the timing of leaving the 3D printer from conversation. Participant C was watching the operation of the device in front of the 3D printer. Then he suddenly muttered, "I see, the first layer." We asked participant C what happened after the experiment. Then participant C answered, "The conversation was presented timely, and I learned from the conversation when I could leave the 3D printer." Even though the tasks are different, conversations containing knowledge were shared because the equipment used was the same. Besides, we could share knowledge through conversations using only location and attention target. Here is a conversation actually presented. He could work efficiently by this conversation. We explain an example where participants were unable to gain knowledge despite the presentation of a timely. One participant is puzzled by laser cutter operation. Therefore, if a timely conversation is presented, can the participant help? However, he does not gain knowledge from the conversation, and over time they solve on their own. Then we thought that good conversations were not presented. However, when we checked the experiment log after the experiment, a conversation with useful knowledge was presented. So therefore, even where conversation was presented in a timely, an example where the user did not gain knowledge could be observed. Let me summarize my talk. We propose a system to facilitate experiential knowledge sharing through situated conversations. We conducted experiments to confirm the effectiveness of our system. Experimental results showed that most of the conversations presented when the situation perfectly matches is related to the user situation, and some of them prompts the user to change their behavior effectively. Interestingly, we could observe the conversations that were done in the same area but not related to the current task also had the effect of expanding the user's knowledge. We also observed a case that although a conversation highly related to the user's situation was timely presented, but the user could not utilize the knowledge to solve the problem of the current task. That's it. Thank you for listening.